Do you like gold? I guess that is yes. Let's do this! Make gold! Alchemist time!
Today we are not chemists but
Alchemists! Magic!
And today let's take this gold with these three colorless solutions.
We're gonna make gold with these.
They are lead nitrate, potassium iodide, and glacial acetic acid. Wanna know how? Let's go!
It's go time!
First off, get around 3 milliliters of glacial acetic acid and add it to around 10 mils of water.
It turned a wave pattern now.
Just like last time when I put in the sulfuric acid into the water.
Yeah.
Okay, now that we have our acetic acid, let's add our lead nitrate. Why I add the acetic acid was to prevent any side products from forming which could bother the reaction. Here I have 0.5 grams of lead nitrate. Let's now add it to our acetic acid water mixture.
I smell something.
Oh, that's probably acetic acid because acetic acid is actually the acidic component of vinegar, and the glacial acetic acid is kind of like vinegar except much stronger. You see, vinegar is a 5% acetic acid solution, whereas the glacial acetic acid is 99.8%. To our other one, let's add approximately the same amount of potassium iodide. Let's go ahead and wait for both of these solutions to dissolve. And also guys, don't be alarmed if your potassium iodide is a little yellow or something. It's completely okay.
If it turns yellow, what happens?
Well, you see, the iodide ion can easily give up electrons, forming iodine. Oxygen wants electrons, so it might oxidize some of the iodide ions to iodine. And then the iodine and iodide will complex, forming triiodide, which, due to its low concentration, will be yellow. Now everything is ready. We have our lead nitrate, potassium iodide, and hot water.
What happens if you put other one to the other one?
Well, let me show you. First off, let's add dropwise. Ready for some cool stuff?
Ready.
So, wow.
Wow.
A brilliant yellow color.
Alchemist magic. This is actually real gold. This was actually fake gold.
Now, let's just add all of our potassium iodide.
It turned really yellow now. It looks like honey. If you wait for a little bit, it'll turn goldish.
Well, not yet.
Yeah.
So first, let's transfer it to our larger beaker. A good yellow color. Soon, this will give us gold.
We'll be rich!
Filthy rich.
Yes, we already have gold right there. Gold.
It takes about 30 minutes of time. So, see you in 30 minutes. Bye. Now, the gold is ready.
Let's check it out. The gold is ready. You can put it in something kind of like this, and it's a great gift. You can make a souvenir like that.
Called?
Called gold globe, not snow globe, okay? Because it's gold, not snow.
Get it? Now guys, to be honest, this was not gold. It was actually something known as lead to iodide. Hope you guys liked it.
Enjoy your souvenirs!
And see you in the explanation. Bye!
Hope you guys like it. Subscribe and like.
Now, let's see what happened in the golden ring reaction. The first one is the one with potassium iodide and lead nitrate right here. You see, lead nitrate and potassium iodide react together, forming potassium nitrate and lead to iodide. Lead to iodide is one of the 4 insoluble iodides, along with silver iodide, mercury 1 iodide, and mercury 2 iodide. However, potassium nitrate is soluble as the nitrate salt. So the potassium nitrate will remain in solution, whereas lead iodide will precipitate as the yellow solid you saw earlier. However, you can do exactly the same thing with virtually any other soluble lead salt and any other soluble iodide. Now you might wonder how some of the precipitate dissolved as I added hot water. Well, here I wrote the solubility of lead to iodide at different temperatures. Room temperature, it's around 0.76 grams per liter, while at 100 degrees, it's around 4.1 grams per liter. You can see that solubility significantly increases as the temperature goes up. However, because my solution is cooling down, it will eventually crystallize as lead to iodide again. Here I drew a beaker, and here is one lead to iodide molecule. The lead has a 2+ charge, while iodide has minus. As more and more stuff precipitates, the iodide ions and lead ions will be attracted, going into a crystal structure, like this. These extremely tiny crystals keep growing until they make shiny crystals that resemble gold. Next up, I will write you why I highly recommend it to use distilled water. You see, tap water contains chloride ion, Cl-, and lead is lead 2 salts actually have insoluble chloride, bromides, and iodides, not just iodides. Just like silver 1 and mercury 1, lead 2 will precipitate when it meets chloride ions with the following equation. What I wrote here is that 2 chloride ions react with 1 lead to nitrate molecule, forming 2 nitrate ions and lead to chloride. The only insoluble nitrates are bismuth and antimony oxynitrates, so the nitrate ion will remain in solution. However, lead 2 chloride is not soluble, just like silver chloride and mercury 1 chloride. Therefore, it will precipitate. However, if your tap water has too much chloride ions, it could precipitate too much of the lead. So, I highly recommend using distilled water. Thanks for watching, and see you in our next videos. Bye!